morning everyone. So today we will look at the experiment of diffraction. Now this is a tabletop spectrometer that is there, and you have a white light source which is a mercury source that is there. The different parts of this particular instrument include the collimator, the prism table, the telescope. So if you focus all three in one particular direction, that is, let's say along the same straight line as that of the source, if you align it, you will end up getting one bright slit that is there. Now, we can have a look at this part. This is the slit of the collimator. So you can see we have got a spring screw here. On turning it, the slit opens. Now the slit that is there ensures that the wavefront from our source that is there, this white light source, it reaches the collimator. It is collimator. So the collimator ensures that the rays that are falling on it are parallel. We keep the slit as narrow as possible to get one single fine line. Now, and as the rays pass through the telescope, we are able to resolve and look at this slit that is there. Now, on the prism table, we can keep a prism to look at minimum deviation, or we can use a diffraction grating, which we will be using in this particular experiment. So this is a diffraction grating, and here you can see it mentions 15,000 lines per inch. So that means in this particular grating, you have 15,000 lines that are drawn per inch. Now this is going to disperse the light rays that are coming from this source that is there. So generally what we do is we place it on the prism table. So you have a grating holder here. We place it here in this particular slot, and we view the dispersed light that comes from this. Now in a regular dispersion that is there, we can see that we have 7 colors. So you take white light, you disperse it through a prism, you end up getting 7 colors, starting with violet, ending with red. Violet has the least wavelength, whereas red has the highest wavelength. Conversely, violet will have a high frequency compared to red, which will have a low frequency. Now, characteristics of the source is it's a white light. So we will have to ensure that this source is kept on for quite some time before we can begin the experiment. Because as it starts off, you can see that it is giving out yellow light, but once the filament gets heated enough, we end up getting white light. So this is aligned in such a way that this light falls on the collimator and then it collimates the rays. Dispersion happens through the diffraction grating, which is viewed through the telescope. An important part here is to know how we can take the readings. So here we've got a vernier scale that is there. So graduations of your vernier scale are from 0 to 30. The remaining are your main scale divisions. So we can, let's say, rotate this turntable that is there and get different values for the readings that are there. Before we begin the experiment, we have to take one reading called as the direct reading. That is, without placing the diffraction grating on the prism table, we will have a look at the slit that is there. So the image that we get, which we watch through the telescope, is what we are going to see. That reading that we get from here is your direct reading. When you look at this, I have left the source on for 15 minutes. So right now you can see instead of yellow it is white. And using the same white light that is there, we focused the slit on the collimator and we got the image of the telescope. Now, I have covered it with a cloth here. Reason being very simple. I don't want excess light falling on the diffraction grating and being, let's say, focused by the telescope that is there. So therefore, I have ensured that I have put a cloth here to minimize the excess light that is coming. So whatever light is coming only from the slit, falling on the diffraction grating and is viewed through the telescope. Now one sample of all the lines I will be showing in some time. So here you can see that there is a slit that is open and you are able to see the light in the lens here, in the telescope. So I am going to ensure that my slit becomes narrow. So you can see that as the slit becomes thin, you have a very fine line of white light that is being seen through the telescope. So here you can see it's a very fine line that you can see through the telescope that is there. So the next part of it is we will have to place the diffraction grating on the prism table. Now the prism table is detachable because we can ensure that it's placed at different heights. So right now I'll place it here and I'll lock the prism table. Take my diffraction grating and I'll place it in the given slot. So once this is placed in the given slot, we can go ahead and tighten this here using this screw. The prism table will not move now. We will have to move the telescope either to the right or to the left until we get the diffracted lines that are there. So therefore what happens is we will end up getting two orders of lines that are there. The first order which starts in the same 7-color pattern from violet to red, and the second order which will be a slightly fainter one from violet to red. So we will look at those lines by focusing, and we will also take one reading. So here you can see that after focusing the telescope onto the grating, we are getting a violet light that is there. So for this, let us see how we can take the reading on the spectrometer that is there. So I will take off this cloth, and here you can see that the reading is between 180 to 160, and we've got 30 of the 1-year scales that is there. So we will see which one coincides, and accordingly we will take the value. So that value will be the reading for this particular violet line. So this will be the first order line, and as we see, if we move further, we will finish the first set of Webjer, and then we will get the second order lines that are there. Similarly, we can move the telescope onto the other direction and we will get similar set of lines.